Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students. So today I'm going to start a very important chapter which relates to mathematics, which relates to statistics as well. And the name of that chapter is probability. And you might have uh, done in chapter. Let me check what chapter was it. And you might have done in chapter number 4, collecting, organizing, and displaying data. We have already studied in chapter number 4 of this same book. Now, if I have a coin in my pocket, yes, I have a coin in my pocket, you see that I am going to flip it once and it has ended in a tail. So if I write T over here, now let me write the probability and the outcome. What was the outcome? This is called the outcome of the event. The event is the tossing the coin. Okay, the tossing of the coin. And what was my first outcome was tail. Now, of course, if I do it for once, either the tail will come or the head will come. There were two chances. There were how many chances? There were two chances that now this is an event, and in this event there are two chances which are head or tail, which are head or tail. Now this one out of two. Now one out of two outcome has already seen in my tossing of coin. Now let me repeat this procedure experiment for next one toss more. Now you see it has come. It is clear that it has come head. Now it has come head. Again, if I do it, now let me do it for 10 times. 2 and 8 times more. And I'll just note it down on my book and then I'll transfer it to, I'll reproduce the same result on the board. It is T, it is again T. Now I have completed my experiment for 10 times. You see, 1, 2, 3, 4 T's come in a row. 1, 2, 3, 3 T's come in a row. Then head, two heads, then T, then head, 1, 2, 3, 4, 5, 6, 7, 8, 9, and yes, 1 T again. Now you can see the result. The result is obvious that you see that if I count 1, 2, 3, 4, 5, 6, there are 6 T's, and of course, out of it is 4 heads. The ratio is approximately 50%. It is approximately 50%. And when you keep on doing, when you keep on tossing the coin, maybe for 100 times or 50 times, you will see that it will become more closer to the 50%. Each outcome will be 50%. Okay. Now, what is probability? Probability is the study of chance. It is the study of chance. Now, what is the probability? As you have seen, my dear students, that this was probability. What I did was the probability. Sometime it came head, sometime it came tail. And what the probability is the study of chance and how likely it is that something will happen. How likely? It is equally likely. I said that it is equally likely, an equal chance of head was there and equal chance of tail was there. There was an equal chance that head will appear on the top, and there was an equal chance of that the tail will appear on the top. Now I can say it that whenever we are unsure about the outcomes. Now I was unsure about the outcome. I don't know whether the head will come or the tail will come. This was the unsurety. This was the unsurety that the head will come or the tail will come. Then, then we say about the outcomes of the event. When we sure about the outcomes of the event, we can talk about the probabilities of certain outcomes. We can talk about the probability of certain outcomes, how likely they are. As I told you, that how likely they are. That means the tossing of coin. The tossing of coin was that either the head will appear or the tail will appear. Either the head will appear or the tail will appear. Okay. Now, if you have a dice, you see, if you have a dice, there are 6 faces. If I make a dice over here, now there are 6 faces. Let me reproduce these faces in a single plane. Now there is one face. This has 2 dots. This has 3 dots. And this has 4 dots. And then this is 5 dots. And in the last, it has 6 dots. So this is a dice. When you play, when you roll the dice, 1 out of 6 faces will appear on the top, not on the sides. For example, if this is the dice, this is not a dice, this is a duster. Well, when you roll this duster, when you roll this dice, when you throw this dice, the top the top face will be considered. The top face will be considered. For example, when you roll the dice, either the 1 will come, either 2 will come, either 3 will come, 4 will come, 5 will come, 6 will come. Now it is not possible. Now what I was going to say, that sometimes that is impossible to have a values of. Now it is impossible that you can get 2 of faces on one dice at one time. It is not possible. No, that is why we say that something that is impossible, and has a value that is equal to 0. Now it is not possible. So to get the two values, maybe this, maybe this, maybe this, maybe this, on one dice at a time. On one dice at a time, maybe if there are two dice, then you may have 2 faces, yes, but for each dice, again, it will be one face on the top. Okay, understand my mind? No, it is impossible to have 2 faces, so the value will remain 0. So the value will remain 0 over here. And there is a certain thing that one face will appear. Now one face will appear at the top. That is for sure that you will get one face, 1 out of 6 face. That is for sure that you will get one face out of 6 faces on the top. Now it is certain that it is 1. But when you say the probability, now this is the scale. This is the probability scale, that one face will appear. Yes, one face will appear on the top, but what is the probability that one face will appear, that what is the probability that 2 will appear or 3 will appear or 4 will appear on the top? That is 1 by 6. That is 1 by 6, because there are 6 faces on the dice and each face has an equal chance of coming on the top. Each face has an equal chance of coming on the top. So there are 6 faces, 1, 2, 3, 4, 5, 6 faces. So one face has an equal chance of coming. So it the probability of each face, the probability of each face is the probability of that face divided by the total number of faces which have on the dice, which are on the dice. There are 6 faces on the dice, so it it has 1 by 6 chance of getting on the top. This has 1 by 6 chance of getting on the top. Similarly, up till this has 1 by 6 chance of getting on the top when you roll the coin. Similarly, in our example of this, in our example of the head and tail, there is a chance, there are two outcomes, there are two possible outcomes. Now here there are 6 possible outcomes. Here there are two possible outcomes. Now when you say two possible outcomes, that means the chance of one face is 50% or 1 by 2. Chance of one face appearing one face is, this is the equally likely, this is equally likely, this is equally likely. That means both the faces have an equal chance of getting on the top, so there are how many total chances, or there are how many total faces? There are two faces, and getting on the top is only one. Therefore, the probability of each head or tail is 1 by 2. 1 by 2. And if we just multiply this with 100, it will become 50%. To get the percentage, it will become 50%. Let me give you another example. I have told you about that. Now this was the probability scale. This was the probability scale from 0 to 1, because there is not a possibility, there is never a possibility that two faces will come. Okay, now there is possibility that one face out of 6 faces will come, this is for certain. But which face will come, this is the probability. Now this is a little minute difference in there is a line between the two, which I am telling you. This is a line between two. That the one is that 1 out of 6 faces will definitely come on the top. Okay, and 1 out of 2 faces will definitely come out on the top. But what is the probability? Here the probability is of 1 by 2, and here the probability is 1 by 6. Similarly, 0 and 1, it is what it is called? It is called the probability scale. Probability scale. Every probability will fall between 0 and 1. 0 and 1. Every probability will fall between 0 and 1. For example, you see that there is 1 by 6 chance, 1 by 6 chance of getting 1 or 6 on the dice if we roll the dice. There is 1 by 6. If I just multiply it with 100, if I multiply it with 100, then you will see that this whatsoever it will become will be in percentage, and this will be more than 0, and this will be more than 0. This will fall here somewhere. Okay, and it is not 1, because it is 1 by 6, so it is less than 1 and greater than 0. It is less than 1 and greater than 0. If I roll the coin. Similarly, you see that there's a 50% chance. That means there is 1 by 2% chance. 1 by 2, I told you that 50. This has come 50%. So 50 comes over here, somewhere here. So you see that half comes over here, which is 50%. Okay. Now it falls between. Now you see that it is exactly in the middle, more than 0 and less than 1. More than 0 and less than 1. Though this is the probability scale, and probability always lies between 0 and 1. Probability always lies between 0 and 1, and probability cannot come below 0. Now below 0 is -1, -2 or -3, and so on and so forth. And it is from 1, it is 2, 3, 4. Now probability cannot go beyond below 0. Probability cannot go below 0, or it cannot go beyond 1. It is time. This is this point is to be remembered, that it cannot fall below 0, or it cannot go beyond 1. It cannot go beyond 1. Let me give you another example. Then you will find. Now suppose you have a shopping bag, okay, and there are how many? There are oranges and apples. In the orange, the apple is red, and the orange is okay. Oranges, oranges. The color of orange is orange. Okay. O. Let me write it O. There are many. There are many apples. There are many apples here, and there are many oranges over here. Okay. And what is the probability? Now you see that there are two things. Number one, there are apples in the basket or in the bag. There are oranges in the bag. Now there are two things. Now if I take them as one commodity, that is a shopping. That is shopping. Now if a fruit, if I take them as a fruit, now both are the fruit. Both are fruit. Now what is the probability that I'll fetch one fruit out of it? It is again 1. Yes, it is 1, because each time I'll fetch one thing from the bag, it will be fruit. It will be a fruit. But what? Now listen my point. Now you listen my point carefully. When at random I want to fetch an apple, from the basket, now there are how many things? There are 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Yes, there are 10 fruits in this basket. There are 10 fruits in basket. So if I want to fetch one apple out of it, now what is the probability? Now, the probability of fetching the apple, of drawing the apple from the, is 1, 2, 3, 4, 5. That is 1 upon 5. That it will become 1 upon 5. Now there are how many things in the basket? There are 10 things in the basket. In fact, there are 10 things in the basket. So the total probability of fetching one apple from the host basket will be 1 by 10. Now my dear students, let me proceed. Now what I Now what is probability? Probability, if I write it in the equation form, it will be possible choices. This is possible choices. Possible choices divided by the total number of options. The total number of options. It is total number of options. Total number of options. Yes, I told you in the dice that there are how many total number of options? There were six number of options. 1, 2, 3, 4, 5, 6 number of options, and possible choice is only one. Okay. Now the probability that one face will appear is that 1 will appear, that 2 will appear, 3 will appear, 4 will appear, 5 will appear, 6 will appear, 7, no, not 7, only 6 will appear. Maximum 6 will appear. The possible choices is 1 and the total number of options are 6. There are how many? 6 options. Okay, now let me proceed furthermore. Now we can also forecast about weather. We can also forecast about weather. Will it rain today or will it not rain today? Now there are again two possibilities. Will it rain today? Rain or not rain? Now, when I say not, now let me take to this little. When I forecast that it will rain, certainly it is that it will rain or not rain. So when I say not rain, that means I have the probability that 1 minus of the probability which will rain. It will rain. Now this is what you will not understand at this point. Now let me write this thing in a little different manner. Now probability of A. Probability of A is equal to, again we have number of times A occurs. Number of times A occurs. Okay, and total number of possible outcomes. Total number of possible outcomes. Okay, outcomes. Yeah, write it, outcomes. It is one and the same thing. And for what I said, not rain, and I say not rain, it will be P not rain. P not rain. The first was that the P that will rain. My first forecast was certain that I was it will rain, and I the second thing is that it is not A. It is not A. A is rain, and not A is that it will not rain. And you can say, you can write here not A also. You can also write here not A. Okay, which means it will not rain. Okay, now that is equal to 1 minus A. That is equal to 1 minus A, and of course 1 minus 1 is 1, of course, and A is the chance which was 50% that it will rain or not rain. So definitely the P that not A is again 50%. Understood my point? Understood my point or not? Or we should proceed? Okay, now this was the probability. I told you about the coin, flipping of the coin. I told you about the dice. I told you about the oranges and apples. And now let me take what is the definition of what is frequency. Now let me tell you what is frequency, which is very important thing. And the I've already write I have already written the frequency over here, but up till then I didn't told you about the about the frequency. Now about frequency. Now frequency. Then we'll be learning relative frequency. After frequency, then I'll be telling you what is the relative frequency. The number of times a particular uh, value occurs in data set. It is the particular value. It is the particular value which occurs in data set is called frequency. Is called frequency. I should have multimedia. I should have a multimedia, but I don't have it so far to show you the slides. Uh, it is my constraint. So, a particular value which occurs in a data set. For example, for example, for example, what I did in the first tossing of coin. 1, 2, 3, 4, 5, 6. And the events I noted were tail, 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 head, tail. Now, the frequency is what? Particular value. It is the particular value. Now, frequency of tail. Let me calculate the frequency of tail. In the 10 outcomes, 1, 2, 3, 4, 5, and I know it was 6. It was 6 in my first experiment in the beginning. It was 6. Frequency of T was 6, and frequency of head was 4. Out of out of 10 outcomes. It was 10 outcomes. The frequency of tail were 6 out of 10 outcomes. Frequency of head was 4 out of 10 outcomes. This is head. And I told, now for the frequency, there is one thing which is also considered. It is a grouped data or a group data or ungrouped data. Ungrouped data. It is a group data or it is an ungrouped data. I'll see that do we have this in our course or not. Since I think in your first lecture it is not there. Okay, so let me leave it for next. What is a group data and what is ungrouped data? Now you see that frequency. What is the frequency? Now frequency means, what is frequency? When we are in physics, this is frequency. Now if I relate both of the things, or if I relate both of the things together, the frequency, if I say the frequency of t, now you see that t is coming again. T is coming here. So it is coming again and again. So it means that the outcomes of total T's is the frequency. The outcome of total T's out of this data is its frequency. And total H heads is its frequency. Understood my point? And what is the relative frequency? When we say a relative frequency is the number of times the particular outcome occurred divided by the total number of outcomes. It is very easy. That relative frequency of the number of times a particular outcome occurred, it is, let me write it, a number of times a particular a number of times a particular outcome occurs. Outcomes occurred. This is divided by. I'm sorry that the board is very small, and I don't have. Yeah, I just told you that I don't have slides. I would have uh, done this on the slides because it is much more better to show you slides rather to write it over here. It is divided by the total number of outcomes. Total number of outcomes. Total number of outcomes. Okay, it is the number of times the particular outcome occurred. Particular outcome, maybe say T, it is particular outcome. When I say T, then it is a particular outcome. Now the relative frequency of T is 6. The total number of outcomes divided by total number of outcomes is 10. Now the relative frequency 6 and total number of outcomes 10. So this is the relative frequency of T. Or it can also be written. Where should I write it? In short, it is written as relative frequency. RF is written as RF is equal to F. F. F upon N. The total number of outcomes. Total number of outcomes 10. It is the relative frequency, which is 6 in T and 10 total number. 6 upon 10 is the relative frequency. So my dear students, let me see what is coming ahead of us now. I hope you would have understood what I taught you today. Now I am going to tell you a very interesting example which I read in when I was studying probability. A car. There was a parking space. There was a parking space here, and a car came and he parked his car over here. He parked his car over here. And what a man who was studying probability, maybe, he just chalked. He just made a mark of the walls on the tire. There is a wall on the tire from which you uh, from which you fill the air. From which you fill the air on the tire. There is a wall in each tire. So he marked. Now suppose that the wall was here, the right wall was here, it was here, it was here, it was here. Okay, the wall was here, 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 here. He just marked on the road here, 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 here. Okay, he marked the walls. Now you see that this man went back after what he now this man left the parking space after some time. This man left the parking space after some time, and what happened next is very interesting. Okay, now he left the parking space after some time. He came back. He came back to the same market, to the same parking space, to the same parking space. And the interesting thing is that he just parked his vehicle, his car, right on that very space where he parked it in the morning. Suppose that this was the parking space, and this parking space was, the number was 6. The number was 6. The number of parking space was 6. Here it was 5, here it was 7. He got the same space. He got the same space here after coming back. After some times, maybe in morning he came and in evening he came. Okay. When he came from the road, he saw that number 6 is empty, is vacant. So he parked his vehicle over here. He parked his vehicle over here. And the next thing is more important, more interesting. What he noticed, that all the walls were right at the same position where it was in the morning. All the walls were right at the same position, right at the same position where it was in the morning. Now there is a probability. Yes, there is a probability that it can happen. Thus, yes, it can happen. But the probability is very, 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 very small. Yes, it can happen. You get the same parking space, and when you get the same parking space, your walls are right at the same position where it were in the morning. It is the probability, it is a question of probability, and someone had calculated its probability. And someone had calculated its probability even. Okay. Now this was the example. Now there is an example coming up, and then I'll call off my uh, lecture for today. On page 161, suppose that blindfolded man is asked to throw a dart at the dartboard. So you know what is a blindfold? Blindfold means when you tie a piece of cloth uh, on the eyes, when you tie a piece of cloth on that eyes, and you cannot see, it is a blindfold. Uh, if he hits, for example, this is a dart, and he hit on the board, dartboard, on which dartboard is on which the numbers are given. 100 bullseye. What is a bullseye? You know what is a bullseye? Bullseye is, for example, if it is a dartboard and here it is 100 written over here, maybe 100, 200, whatsoever it is written. It is not necessary that it is 100 should be written in the bullseye. Bullseye means the center of the dartboard or the center of your. Now this is the dartboard. For example, 100 is written. Now this is bullseye, and now if he hits blindfoldly here, blindfoldly here. Obviously, he is blindfold. So when he is hit, some will strike outside the board and some will strike inside the board, and maybe on the bullseye as well. So what is the next line? If he hits number 6 15 times, now there's a 6 number over here. Now he hits this 6 number 15 times out of 125 throws. Now, yes, I was going to tell you about the trial. I just missed the trial. Now, what is a trial? When you keep on trying the things, when you keep on trying the thing, for example, I was rolling the dice, I was tossing the coin, Now, this experiment is called the trial. Experiment or trial? Trial. Performing experiment. Yes, it is performing experiment is called a trial. Okay. So if I take it as a trial, now there are how many there are 125 throws in total. 125 throws blindfolded. Blindfolded. And out of 125 throws, you see 1, 2, 3, and 125. 125 throws. Okay. 125 throws, out of which 15 throws hit 6. Out of 15 throws hit 6. Okay. Now, what is the probability of 6? Probability of 6 is equal to number of times 6 is obtained. Number of times 6 is obtained. Number divided by the number of total trial, number of trials, or number of throws. You can also say number of throws. Now manipulating this, it will be 15 divided by 125. Simple. It is 15 divided by 125, and when you solve it, it will become 0.12. Now the probability was 6. So, probability of 6 is 0.12. Now what does this result show? What does this result show? That the probability of hitting the 6 is 0.12 or 12%. Okay. And if I ask him, now it is the most important feature of the question which has been asked to you. The next line is, what is the probability that in the 126th throw, he will hit 6. He will hit 6. Out of 125 throws, he has only hit 15 times, and the probability has come to 12% or 0.12. Okay, then it is obvious that the probability will remain same for 126th throw, and that is only there is only a chance that 0.12 is the probability that he will hit again on the 126th event the number 6. And what I told you in the beginning, not hitting 6. When I say it not hitting 6, then it is not 6. Okay, it is not 6. This is not given in your example, but I am adding this. Not 6 is equal to 1 minus 0.12. It is 1.12. Okay, now it will become 0.88. 0.88. Okay, not hitting 6 is 0.88. If I done the calculation right, 90 and 100, yes, it is 0.88, and hitting 6 is 0.12. So you see that I already told you about not and the desired event. Now this is the desired event. You can also call it the desired event. Sometimes it is called desired event, and this was the not desired event. This was the not desired event. So my dear students, this is all I can have today, because time is running up and you'll get bored in and listening me, because you are not doing any questions so far. Okay, my dear students, time to say you goodbye. Allah Hafiz.